Okay, so there's some development underway here. I simplified the stack out. You see there's just a Raspberry Pi Zero now and sensor board on top. And what I've done, like around this side, is I've got a little GPIO breakout there to make it easier to access the headers. And then that's connected up to the Note A, I think it is. And that's got a note carrier A, and that's got a note on it. And then what we're seeing broken out of that header is I've got a couple of wires providing power, the red and the orange. That's because if we go in through the header as opposed to going in through the mini USB connector, which is just over here, I think that's got a regulator in the way or something. We save a lot of power if we go in through the header. Next thing, there's a couple of pins that are taking out the I2C connection, and that's going into the Raspberry Pi, so the Raspberry Pi can talk to the board. And finally, we've got a little really cool actually, little Tony on-off device from Tindy. And what that is it's got USB going in, USB going out, and then if you set an enable pin, it sort of turns on the output, turns off the output. So basically what we're doing is we're using the Raspberry Pi Zero over here, we're using the Note over here to assert an activity pin which turns on our Raspberry Pi Zero, which is then connecting up to the cloud and doing all sorts of magic stuff. So over here you've got a power brick which is powering all this good stuff, and all the other bits of wire are because I'm doing some power metering to have a look at what we're actually taking. Now, yesterday I had this down to about 15 microamps in sleep, which was really pretty good. We're running at about 320 microamps, but I've just got this under test. I think we can get it back down to 16. Okay, now what we have here is we have the Raspberry Pi on. This is connected up to the interwebs. And if I just do, there's a note card command which talks over the I2C bus. It's got a serial over I2C protocol, also very cool. This is all the Blues stuff, blues.io. And then that's gonna sort of talk over the I2C bus to the Note, asking it various bits and pieces. So that's telling us it's alive and up and running. And then what I'm gonna do is, I've got this, let's just get rid of that, yeah. So if I paste in here, I've got a command to send to the hub, to the Note rather, and what that's going to do is it's going to put it into a sort of an armed sleep mode for 20 seconds, and that will take the attention pin, it's called, down low, which in turn will turn off the power to the Raspberry Pi. And what we're going to see is that little power LED, the green thing, is going to go off, and Pi is going to be off for about 20 seconds. Let's do that. Boom, turned off. Really, really nice. So if I just show you the state of this pin, I can do that. Yeah, there we go, get onto that. That should be low, and within about 20 seconds, assuming that I'm sitting on the right pin here, that attention pin is going to go high out of the Note. So let's just wait for that to happen. Can't be much longer now, one would hope. There we go, went high, boom. Raspberry Pi is now starting up its boot sequence. Isn't that nice? So you can see now what we've got is we've got the ability to put this very low power communications Note device into a sleep. That will cause the main unit that's doing all the grunt work, as it were, to be turned off, saving power. And then periodically, or on other events actually, on sort of messaging events or motion events or location events, we can have that turn on our main unit, and we can do whatever sort of edge computing we want to do, having been turned on. Now the Raspberry Pi Zero is not the most powerful beast, so it's taking a little while to boot up. One of the points about this is that I'm going to be working on a much faster mechanism for booting the Raspberry Pi in a bare metal mode, which some of you may have seen in the future. But basically the sort of point is proved that we can sleep in a very low power, 10 to 100-ish microamp kind of range over long periods of time on battery. And then based on a variety of different events, we can wake up a more powerful host processor and get it to do its thing. So really pleased with that. I know it's very messy, but this is real engineering. I will do a tarted up version of the stack where everything's nicely laid out and ready to go when we're getting ready to put this into the first study, which is going to be the B study. So hope you enjoyed. Thanks. Bye.